Okay, so now we want to find the central angle of a regular hexagon. So this is a 6-sided figure. I'm going to go ahead and slice and dice this up into some triangles. And if I go ahead from this center angle where they'll all intersect, and I draw a circle here around these points, I'm going to try to make this as even as possible. Looks pretty, okay, good. So we know that circle equals 360. We can divide by our number of little triangles there, or the side lengths of a hexagon, which is 6. 360 divided by 6 tells us that each central angle equals 60 degrees. And we can use this process for any regular polygon. Okay, throwback to Unit 7 trig. Woohoo, everyone's favorite, SOHCAHTOA. You are given this lovely, lovely, lovely formula on the reference sheet. But as a quick review, if we're given a 30, 60, 90 triangle, remember that this guy right here is 2x. This guy over here, J, would be x radical 3. And then our buddy K is x. So if you're given this one side length here, we would know that 2x equals 24. Thus, x equals 12. And then you just plug in 12 for x on everything else. But once again, this guy right here will be given on your reference sheet. So you can refer back to that. Okay. Keep on moving along here. General formulas for finding the area of a regular polygon. So it is 1/2 times your perimeter times the super duper cool word called an apothem. And that is just simply a line from the center of a polygon that is perpendicular to any side. This bisects the side of a polygon as well as the central angle. So it creates a right triangle that can be used to find the missing length as needed. So a lot of words in there, there's a lot of drawings. Let's just get right into it and start working through. So we're given a regular hexagon here, and all that we're told is that the side length is 16. So if I roughly estimate my central angle there, I'm actually going to move this up just a hair. The apothem goes from that central dot and bisects your side length. So when we bisect that, that cuts it in half, making this side 8 and this side 8. We also now have a right triangle, and we can go ahead and find our desired missing length, which would be x here. This is your apothem. So how we do that is when you're given a hexagon, we know that from what we just solved up above is that the central angle here would be 60 degrees. And if it bisects it, that means that this angle in here, half of 60, would be 30 degrees. And then that leaves this remaining angle here to be 60 degrees. So we now have a 30, 60, 90 right triangle. And if I just go ahead and draw it out over here, pretend I cut out a nice little slice of it. I am recording this video at 4 in the morning. A nice piece of pizza sounds lovely right now, but I don't really know who makes pizzas this size. Not also sure what happened to that triangle there, so let me redraw it. Okay, so we have side length of 8. Here's my 90, my 30, my 60. So when you are given that short side there, we know that our x value over here, which is what we're trying to find, is 8 radical 3. And then also just for fun, if we wanted to pretend this is the error test, this would be 2 times your x value. But again, we only are concerned with that x value. Okay, so back to finding the area. So we know area equals 1/2. Now I'm going to do a shortcut method, and then I'm going to go ahead and solve it the same way, and we'll get the same answer. So if I do 1/2 times 8, which was the side length of my triangle, times our apothem, or height, which was 8 radical 3, I'm going to solve this and then multiply it all by 12, because we made 12 small triangles in here. So it would be like 1, 2, 3, 4, and I could keep going around and drawing these like such to get my 12 small triangles. And when I do that, the area equals 665.12. Now the formula says go around and find the perimeter. So if I did that, that would mean we had 16, 16, 16, 16, 16, 16. So our perimeter, you would add up 16 6 times to get area equals 1/2. Your perimeter, when you do that, is 96. And then times it by 8 radical 3. What do you know? You do, in fact, get the same exact area, which makes me happy. So you can do it one of two ways there, whatever your heart's desire. All right, last page here. We're going to find the area of a regular pentagon given a side length of 6. So 6, 6, 6, 6, 6. And this is a pentagon, 5-sided figure. Super cool stuff. All right, so roughly draw your central angle. We're going to make our triangle. Remember, life is just a bunch of triangles. When in doubt, draw a triangle. And that line down the middle there is my apothem, not to be confused with Gotham. I know people like that city, but this is an apothem. We are in geometry class. Okay. So when the apothem bisects our side length, we split that right down the middle. 6 divided by 2 gives me a 3 on each side. And we are looking for the height here. So this is the only tricky part. We do not know what our central angle equals here. So we have to go back and first find the central angle. And we just do that, remember, 360 divided by your number of sides, which in our case is 5. So the central angle equals 72 degrees. Now that is the whole blue angle. So you may be asking yourself, well then what does this angle here in green equal? Well, we would just simply divide 72 by 2, so that equals 36 degrees. Okay, so now I'm going to go ahead and draw our little sliced triangle out. Let's just pretend that I was able to pull this out. This triangle here now has become this triangle over here. So let's label the factors that we know. We know this is 3. We are looking for the height. We have a 90-degree angle. This angle is 36 degrees. So then we can go ahead and use SO, CA, or TOA. So if we're given an angle of 36, I have my opposite side and I have my adjacent side. So I go back to my handy dandy formula at the bottom of page 1, and I say which one gives me opposite and which one gives me adjacent. Well, if I start at sine, nope. If I start at cosine, nope. If I start at tangent, Yes, it does. That is your opposite and your adjacent side. So we are going to use tangent of 36 equals 3 over h. And we want to find our h value. So I'd have to multiply both sides by an h here to cancel those out. So h times tan of 36 equals 3. And then let's go ahead and divide by tangent of 36 on both sides. I wish I was tan right now, let me tell you. When is summer? Okay, sorry. So h equals 4.13. And we just did all of that legwork, and we still have to go back and find the area. All of that was just to find the height or the length of our apothem. So now that I know that's 4.13, I can go ahead and find the area by saying, well, we had 6, 6, 6. We had 6, 6, 6, 6, 6. So my perimeter is 5 times 6, or 30. And then my apothem height was 4.13. And when I do that, the area equals 61.95. So good stuff so far, folks. Remember, you also could have done the other way and done area equals 1/2 times your triangle side length of 3, so this guy right here, times your height, times the number of small triangles you could make, and you would still end up with the same answer. Okay, moving on to our regular octagon. This is an 8-sided figure. So same type of process here. We have to make a triangle. That's a terrible color choice. What am I doing? Make our triangle here. We're gonna split this bad boy right down the middle. And we are told that that 25 actually belongs on this side and on this side, so on our hypotenuses. It's going to look a little messy here just to start. But let's go ahead and find the central angle. 360 divided by 8, which is 45 degrees. Remember, since that is this whole entire angle, we have to divide that by 2 because our apothem bisects it. So we actually end up with a 22.5 degree angle. What a beautiful looking angle. Okay, so let me go ahead and pull out this slice of triangle that we just made. And we know that this hypotenuse length is 25. We just found that this angle here is 22.5, and we want to find our height of the triangle. So from our 22.5 degree angle, I can use adjacent over hypotenuse, or in our case, ca. So cosine equals adjacent over hypotenuse. X over 25. And this one is a beautiful, nice, easy problem here. So you just multiply by 25 on both sides. Those will cancel, and you'll end up with our x value equaling 23.1 equals x. Okay, so this guy here equals 23.1. So now we don't know any of these side lengths to be able to find our perimeter, do we? No. That's a great question, Mr. Chmeda. How could we find it? Well, if we look at our triangle here, we can find this missing side also using SOHCAHTOA. So you kind of have a choice here. You could, I'm going to go ahead and erase my previous arrow here. you could either do opposite over adjacent, which would be tangent, or you could do opposite over hypotenuse, which would be sine. I'm going to pick sine because it is 4 in the morning on a Tuesday. So sine of 22.5 equals, we'll just go ahead and call this, let's go ahead and call it y, because we just found x, over 25. Once again, multiply by 25 on both sides, and you end up with 9.57 equals y. So this buddy here is 9.57. Okay, so we know that all of these question marks are now 9.57, 9.57. You get the gist. Let's go ahead all the way back and try to find our area now. So a lot of legwork on this one. 1/2. If I add up all of these 9.57s here, well, actually, I take that back. Just one part of this would be 9.57. So then this other part would be 9.7. So we actually have 16 of those 9.57s to deal with. Because remember, the apothem bisects. So that split that perfectly in half, and then 23.1 was our apothem length. A lot of ugly decimals here, got some fractions in it. Plug this into your calculator, it'll help you a lot to get 1,768.536 as your area. And then the perimeter, well, that would just be your short side lengths of 9.57 times 16. So we're just adding up all of this one side of the triangle here 16 times because it's an 8-sided figure. So our perimeter equals 153.12. So a lot of background work there. Good work so far, people. We're going to finish up these last two notes and call it, or these last two problems and call it a day.